Okay, so today we're going to be going over a back titration experiment, and I'm just going to go over all the steps involved and how exactly you should go about solving a back titration problem. So we're going to be given in this situation a weak acid. So in this case, we'll use CH3COOH as an example, and we're also going to be given a relatively strong base, NaOH. And we are going to be given the molar concentration of the NaOH, let's say 1 molar concentration, and we're also going to be given the volume of the solution. So let's say it's going to be 50 milliliters. In addition, we're also going to be given the volume of CH3COOH. So let's say we have 20 milliliters of this weak acid solution. And in addition to that, we're also not going to have the molar concentration of the CH3COOH. So essentially what we're trying to do in this experiment is to find what the molar concentration of the CH3COOH is. And this is going to be a two-step process. So in the first step, what we're basically going to do is we are going to take the CH3COH and we're going to titrate it with the NaOH. So how's this going to look? Well, you're going to have a beaker, and filled within this beaker, you're going to put the 20 milliliters of the CH3COH. Then you're going to take your burette, and you're going to slowly add all of the NaOH that you have. So 50 milliliters of NaOH, and you're going to dump everything into the 20 milliliters of the CH3COH. Now, what's going to happen is that since the CH3COH is a weak acid, it will not be completely neutralized. It will be completely neutralized by the base. And so what's going to happen is that you're going to have some leftover base. So to recap, what's going to happen is that you're going to have a weak acid here and a really strong base. So when you put that really strong base into that weak acid, not only is all the acid going to be neutralized by the base, but you're going to have some base left over. Okay, so now what you're going to be left with is, so now what we want to do is we want to determine what the volume of base left in the solution is. So we started with 50 milliliters, and then some of it was neutralized with the weak acid, but there's also going to be some of it left. So we're going to determine now how many milliliters of NaOH is left in the beaker. All right. So how are we going to do that? Very simply, it's going to be another titration experiment. So we are going to take another beaker, and we're going to fill that beaker with whatever solution we have left in here. And then we are going to titrate it with some acid. So what is this acid? We're going to use, for the purpose of this experiment, some HCl. So this HCl, we are going to know what the molar concentration. So for the sake of this experiment, let's just say it's 1m. And we want to determine how many milliliters of HCl we need to neutralize the whatever base is left inside the beaker. So what we're going to have is a setup where the HCl is going to be fed into the beaker, and slowly the beaker is going to turn pink. So we're going to add phenolphthalein, the indicator, to this. And so when the solution does turn pink, what you're going to be left with is a completely neutralized solution. So this is what the reaction is going to look like. It's going to be NaOH plus HCl, and what you're going to be left with is water and NaCl. Now, we know what the molar concentration of the base is, so it's 1m, but we don't know what volume it has. we know what the concentration of the HCl is, but we don't, and now we know how much HCl was required to neutralize it. So let's say we required 20 milliliters of HCl to neutralize whatever base was left in this beaker. So what you're going to be left with is about 20 ml, let's say. And this stuff is unimportant now. So what we're going to do is we're going to write the equation MV is equal to MV, where we're going to have the base here and the acid here. And we know that the mass, the molarity of the base is 1, and we know that the volume of the base, well, that's something we have to find. We know that the molarity of the acid is 1, and the volume of the acid is 20. So what you're going to be left with is the molarity, the volume of NaOH used is ml. So is 20 ml. So what does this mean for the experiment? So if we started out with 50 ml of NaOH and we put it in some weak acid, and a small fraction of that 50 ml got turned into, was neutralized by the weak acid. And the other portion was completely neutralized by the HCl. And how much was completely neutralized by the HCl? It was the 20 milliliters. So, out of the 50 milliliters, 20 milliliters was consumed by the HCl, and a certain amount was consumed by the weak acid. So to find the amount of the volume of NaOH that was neutralized by the acid, all we have to do is 50 minus 20, which is equal to 30. Therefore, we know that 30 milliliters of the acid, of the base, was used to neutralize the CH3COH initially. Now, how do we find what the molarity of the CH3COH is? So what we're going to do now is we're going to write the equation for the reaction between these two. So you're going to have CH3COOH plus NaOH, and whatever, we don't really care about what happens after that. We do not know what the molarity of the CH3COH is. We know that the molarity of the NaOH is 1. And what volume of CH3COH did we use? Well, if we go back, we see that we used 20 milliliters. So, write 20 milliliters over here. And how much of the NaOH was required to neutralize that 20 milliliters? Well, we found that it was, in this experiment, that it was 30, as seen right here. So with 50 minus 20. So what you're left with here is 30 milliliters of NaOH. So that means that in order to neutralize a 1 mole solution of 30 milliliters of NaOH, you need to use 20 milliliters of X molarity of CH3COOH. And so how do we finish this off now? MV is equal to MV, the molarity of this one, volume 20 is equal to molarity 1, and 30, so X is equal to 30 divided by 20, X is equal to 1.5. So what does this mean? It means that the molarity of the CH3COOH was 1.5 moles in the end.